Welcome back to Spring Into Math 8. I'm Mr. Burns, and today's lesson is content review, so pay close attention. The first topic we talked about so far was coordinate plane in this chapter. Here are some review points about coordinate planes. The basics are that there is an x-axis and a y-axis. The x-axis runs horizontally and the y-axis runs vertically. Where those two lines meet in the middle is called the origin, and that coordinate listed for the origin is always going to be 0, 0. Now you should also know that coordinate planes are broken into 4 different quadrants, and they rotate in a counterclockwise progression. And maybe it's a little different than we would normally see. So quadrant 1 has both positive x values and positive y values. Quadrant 2 has negative x values and positive y values. Quadrant 3 in the lower left-hand corner has both negative values for x and y. And quadrant 4 in the bottom right-hand corner has positive numbers for x values and negative numbers for the y values. Now, when we're graphing, we're usually using this term called ordered pairs. They are locations that are listed on a coordinate plane, and they tell you an exact location on that coordinate plane. Now remember that you always list your x value first and your y value second. The second topic we talked about in this chapter was positive and negative slope. Here's an example of what positive slope looks like. It's a line that slants up and runs from right to left, and we call that having a positive slope. Negative slope is just the opposite. It slants down from left to right, and it slants down toward that negative direction. Now this is a special kind of slope. It's called a horizontal line, and it has a slope of 0. It runs from left to right, and you can see this in any place on the coordinate planes. Vertical lines are what we call undefined slope, and they run up and down along the y-axis. Anytime you see one of these, you can automatically tell somebody that it's an undefined line. The third topic we talked about in this chapter was slope. Here are some examples of what slope could be in real life. The pitch of a roof on your house. Maybe you lead a ladder up against a wall. That creates a slope. And remember that when we're looking at slope, we're looking at the rise over the run, basically a fraction. Here's the slope formula in summary. It's y2 minus y1 over x2 minus x1. You can use this formula when given sets of coordinates, and then you can use that to find the slope of a line that has not been graphed. Here's an example of what I'm talking about. We have the coordinates 3, 2 and 8, 6. We're inserting these numbers into the correct places in the slope formula, and we're getting 6 minus 2 over 8 minus 3. That reduces down to a new fraction of 4 over 5, which is also the slope of a line. The next topic we talked about was slope-intercept form. This is pretty basic. Basically, you have the formula y equals mx plus b. M is always going to be your slope, and b is always going to be where that line crosses the y-axis, or your y-intercept. Now here are a few examples we're going to do together as a review. Y equals negative 4x minus 2. The slope of this line is negative 4, and the y-intercept, or the b value, is negative 2. Again, here's another example we can look at. Y equals 3x plus 7. We can say that the slope of the line is 3, and the y-intercept of this equation is 7. Topic 5. Graphing linear equations using slope-intercept form. The slope of a line describes how to navigate from one point of the line to another. The y-intercept of the line describes the point where the line crosses that y-axis. Once we have these two pieces of information, graphing is easy. Here's an example of an equation that was graphed. Y equals 2x plus 5. We went ahead and put a dot on the y-axis at positive 5. Then we traveled up 2 spots and over 1 to the right, and then again up 2 more spots and over 1 to the right, and connected our 3 spots on the graph, creating the graph of this equation, y equals 2x plus 5. Another example of graphing an equation. Y equals negative 3x plus 5. We know that the slope is negative 3, and the y-intercept is positive 5. So we went up to positive 5 on the y-axis, dropped our first dot. Since our slope is negative, we went down 3 spots and over 1 to the right, and down 3 more and over 1 more to the right before connecting our line. Topic 6. Equation of a line using similar triangles. Write an equation for this line. Now we can see here that there are 3 dots on our graph, and there are some triangles drawn with it to help us write our equation. First, let's think about what is our y-intercept on this graph. Well, we can see here that our y-intercept is at negative 1, 2, 3, 4. We have a negative 4 for our y-intercept here. Then, from our spot on the graph, we can count up 2 and over 1, 2, 3. That gives us the slope of our line, up 2 over 3. Now we can take these two pieces of information and insert them into an equation like this. Y equals 2/3 x minus 4. And that is how we can use triangles to help us graph or find this equation of a line on a graph. That's it for today, guys. Catch you next time in Chapter 8.